Hello and welcome to our channel of webinar Taurus and Halborn. So good morning if it's morning for you, good afternoon, evening, night. We're going to talk about securing tokenized securities from design to deployment, third-party assessment across the SSDLC, the security of the software development lifecycle. So quick introduction, I'm JP, co-founder of Taurus, Chief Security Officer. I've been doing cryptography for approximately 20 years, a lot of security, offensive, defensive. And now at Taurus, one of my responsibilities is to protect tokenized securities on-chain, off-chain, everywhere. And I'm very happy to be joined by Gabi Urrutia from Halborn. So Gabi, would you like to do a quick intro of you?
Hello everyone. So first of all, thanks for inviting me to this webinar. I'm very excited to participate here. So I'm Gabi, I'm the Senior VP of Security and Field CISO at Halborn, leading the engineering team and focus on strengthening the security and resilience in Web3. I'm very passionate about turning cybersecurity into a driver for growth. So I'm here to share any kind of lessons and experience with you and with the audience.
Cool. Yeah, thank you, Gabi. So to the audience, as you can see, we both have very strong background in technology, in security, hacking, not so much with compliance, but we've both been exposed to finance, compliance, and all that good stuff. So here's the agenda of today. I think it will last approximately 40 minutes. We're going to have time for questions at the end of the webinar. However, you can use the chat feature of the platform of Livestorm. Right, I'm typing something right now. Hello. Okay, you should see hello. You can ask questions there or comments or yell at us. We may or may not answer depending on how much time we have and how relevant it is. But we're going to read the chat. Okay, so we're going to start about tokenized securities and blockchains, a very introductory section. Then we're going to focus on some examples of on-chain and off-chain disasters and try to give some insight based on our experience of what to do and not to do on either side of the chains. And lastly, in the third section, we're going to focus on supply chain risks. And it's a very timely discussion, I believe, because as you may know, last week there was a small incident related to supply chain, actually two small incidents. So let's start. And you're going to start after this slide, which is a small, maybe a reminder or a small introduction to what are tokenized securities. So tokenized securities, we're not talking of NFTs or Bitcoin or the new meme coins on Solana. We're talking of actual real financial instruments that have really intrinsic value, such as equity shares, bonds, tokenized funds, tokenized managed certificates, even tokenized real estate to some extent. So which are financial instruments which can be exchanged, can be traded, and recently they can also be tokenized as blockchain assets since a few years, depending on your region. And we usually talk of distributed ledgers because most regulations don't restrict tokenization to public blockchains like Ethereum, but also allow tokenization on private permission systems such as, I don't know, Hyperledger, Canton, or whatever is your favorite permission chain. So we're not talking of new assets. They're just wrappers or some legislation like the UK call it digital twins. Really depends on the context. But they can be transferred on distributed ledgers. And you may also do other stuff such as corporate actions, like dividend distribution and so on. So one example, at Taurus, we've been doing a lot of tokenization. We've been involved, for example, in the tokenization of bonds that are typically issued as a CMT80 token. CMT80 is one of the two main token standards. And thanks to smart contracts and on-chain logic, you can restrict the transfer to authorized investors. as opposed to anyone like with Bitcoin. Okay, so let's do a quick poll. If you click to the polls section on the bottom right, you should see a question. You should see the following question: What what would be your platform of choice for tokenizing securities? Do you prefer public chains or private chains? There is no it depends answer, so you have to choose between one of those two, public or private. So you click one of the two and you hit submit vote. Okay, and people are voting. Okay, we'll give you a few seconds to vote about this. I don't know, Gabby, what is your favorite option between the two?
I mean, I was in the space for the last 8 years, so my favorite is public, but I think in this case, financial securities need like a very different rules.
Yeah, yeah. I don't know if I were to predict, I would probably lean towards public, but fundamentally, I think that public blockchains are really over-engineered, over-designed, and not fit for purpose um, for a variety of reasons. And I really like the idea of a private permission network that only does what you need to do, and which is designed for your use case. But when I see, how the sausage is made, how some designs are created, I'm like, oh, it's not great either. So I don't know. Okay, so we have a majority, 86% of voters, now 82. Okay, but an overwhelming majority in favor of public blockchains. That's
Mhm.
great because we're going to focus on public chains, on public blockchains. So let me click back on the chat. Um, Maybe the points why I could be skeptical about public chains is that by default they really miss what you need for tokenized securities. I mean, like there's no accountability by default because it's fully decentralized, permissionless. So like decentralization means that everybody is responsible, which means that no one is responsible. There is no contractual agreement between the network and the users. It's pseudonymous, anonymous, no governance. So that's quite an issue if you deal with real money because you need someone to go to jail when bad things happen. Also, what's some topic very dear to my heart as a cryptographer, as someone who's been doing security for many years, is confidentiality. I think it's completely demanded that you would use a database revealing all the transfers to everyone and their dog in any country of the world forever. Everyone could see the balance of each other, could see their social graph, so to speak, their financial social graph. Well, you know how it is. And you probably don't want like your competitor to see your company's assets or to see your company's strategy. And as an individual, you don't see your neighbors, your friends, or maybe your spouse to see what you do with your money. And the last point, contingency planning. So if I've seen many participants from institutions, no audio. Mm. Can someone please confirm that you can hear us? Because it would be okay. Okay, that might be a problem on your side, guys.
Yeah.
I hope you can resolve that. Yeah, someone was saying that had no audio. So the last point, contingency. If you work in an institution, you know how important it is to deal with disasters. The DRP, business continuity, and actually the whole DORA framework is designed for resilience, to establish more resilience in the financial ecosystem. And resilience, how do you resilient? How are you resilient if losing the key means losing all the assets forever? So you have to deal with that. Um, so maybe I will hand the microphone to Gabi if you want to elaborate on different ways that tokenized security can address or should address those uh, if working on public chains.
Yeah. So I first of all I do really love how our audience is so real, so idealistic in terms of wanting a public blockchain. But I mean, if you think about it, I love this comparison. Public blockchains are like highways with no traffic lights or police, so anyone can drive in. So That might work for experimental crypto, but as I said before, financial securities need very different rules, such as, as you can see here, accountability. If someone steals, who can be punished,
Mm,
or there are no social contracts or courts that work by default, as well as governance, because the network doesn't know who the issuer is, nor can it freeze assets, and confidentiality, because balances are recorded forever. Imagine, I mean, if every single bank transaction you made were searchable on Google. And finally, I love this contingency, like lose the keys, lose the phone. So, just as an example, we at Halborn last year we saw a project, tokenization project, forced to freeze asset because just an employee lost access to a key and there was no plan B. So for a bank, imagine this. I mean, that would be unacceptable. So in this case, solution is okay, public blockchain or private, but you have to design in roles, signing quorums, and having much more than smart contracts, like recovery processes from scratch, not after the disaster, making all the processes.
Yeah, so let's say, for example, you in the audience, you might be familiar with the concept of dark pool in traditional finance. Dark pool are kind of non-public markets which are permissioned, even though the word is not used. How would you create a dark pool on chain? You would have to obfuscate, encrypt, so to speak, the activity. You would have to use a whole lot of cryptography to make that work. So some projects are trying to make that, to do that, but it's like throwing a lot of complexity at a relatively simple problem just because it's public. And yeah, you mentioned DRP. I have another story. It was a client. They deployed a contract for their token, and then they followed the process and distributed the token. And at some point, they realized, oops, we've deployed the wrong contract. So we tell them, well, the problem is you can just update the code using your proxy, and they say, well, we haven't used a proxy. Uh-oh. So depending on how you deploy, you may or may not be able to patch your code. So you always need to have a plan B, yeah, like Gabby was saying, because things will go wrong in plenty of ways, and usually in very, very bad ways.
Yep.
Let's maybe move on to actual disasters. On the left hand, you have the leaderboard of Rect, rect.news, my favorite source of news for blockchain incidents. So every week, it's really comedy gold to see all those DeFi hacks. And some outstanding ones, of course, are Bybit. I vividly remember on February 21st when it happened. It ruined my weekend. We're not impacted, but I got tons of questions. So I don't know, Gabi, you want to summarize what happened with Bybit for those of us who don't have the recollection of that?
Yeah. So here many attack vectors were exploited. So first of all, it was compromise the account of the developer for the front end of the platform Bybit used to sign transaction, which was safe. So they were able to make a defacement in the website. So they show. So technically, the this was carried out by a North Korean group, apparently Lazarus. So apart from that, a real problem was bring, which is the one of the biggest challenge nowadays, which is the blind signing. So attackers took advantage of that as well, and it was a long campaign, apparently more than 6 months around.
It was
So
very well prepared.
yeah, so I mean it's a very good example, like in security, you know. we no longer ask if you'll be attacked, but we're first like, what about your smart contracts, your cloud, for sure, your internal processes? Because one of the fails, in my opinion, it was this bland signing process. I mean, signing, it's a very sensitive thing, and the team who signs transaction shouldn't be the same thing who check
And that's a very
the
good segue to the next
exit.
part. So blind signing, just to give a quick explanation. So usually, if you guys sign a contract with a pencil or DocuSign or whatever, it's usually desirable to read the contract to know what you're committing to. And it's the same for blockchain transactions. You have your private key, you want to know which transaction you sign. But out of convenience, some staking companies have this interesting feature that Swissborg, the Swiss company, experienced in a very unfortunate way. You would stake your tokens, in that case, Solana tokens, on a validator of that company, Kill in this case. And staking is pretty well designed from a security perspective, because if you delegate your stake to another validator, even if the validator is fully compromised, their key cannot steal your funds. You retain full control of your funds. And you're responsible for staking them, delegating the stake, and unstaking them. The worst that the validator can do is stop doing their job. In that case, you will not get the rewards. So looks super clean. However, to unstake, you have to sign some transaction. A transaction is a series of bytecode or whatever. And out of convenience, staking providers give you an API whereby they will create for you the exact transaction to sign. They call it the unsigned transaction. So you ask, hey guys, what's the transaction should I sign? Okay, there we go. And blind signing is already signing whatever you receive without reading it. So in this context, it would not be a human reading transaction, but a computerized system checking the validity and checking that it matches what is the semantics of what it's supposed to do. And in that case, on the right hand, what allegedly happened is that the staking provider was compromised, and instead of returning the legitimate transaction to sign, the return transaction essentially said, please send the money to the attacker. And the Swissborg custody system signed that, and the money is gone. So you might argue, okay, what's the point, guys? Because Bybit was about Ether, Swissborg was about Solana. We're talking about tokenized securities today. Yes, so the point of this part is just to tell you that it's precisely what we want to avoid and what we must avoid. And it's not like going from one hack per week to one hack per month. Imagine this 1 billion fund, this 1 billion amount is like the pension fund of your state or your region. This could have much bigger impact than 1 billion in an exchange in the UAE with money from God knows where. So we can't afford in tokenized securities this kind of hiccup. So how do we do that? It's hard, like any security problem. And, blockchain is, well, not new. It's been around for maybe 10 years now, but it's still very mature in terms of technology, because technologists often tend to believe that technology can solve all the problems. Technology can solve human problems, yeah, of course. Whereas in practice, as you know, it's more complex than that. It's about design, feature, code, processes, and people. And I think Gabby and I, we've seen our share of horror stories of bad stuff, of people who did not care, and after an exploit, they went to Halbor maybe to ask for an audit. So here's a list, a very non-exhaustive list of bad things that can happen. So blind signing, we also mentioned it. A smart contracts is like unpatchable code where everyone can see not only the source code, but every execution of your code. So the attacker can see exactly what you do when you do it, your intent, your strategy, your timing, your habits. It's like someone watching out of your house your habit when you go to the gym, when you meet your spouse and all that stuff, and they get to know you. And the first part of any advanced attack operation is reconnaissance, getting to know who is your target. And in the blockchain space, it's very easy to get to know your target because you see everything. Phishing and deception, we mentioned, so like Gabby explained, the Bybit incident, it was really a mix of what we call computer hacking in some ways, and also social engineering involving deception in different ways. And yeah, obviously that was a state-sponsored operation, and the money now is financing North Korea's fireworks. Supply chain, we're going to mention that in the next part. So I think what we really want to say here is that tokenized securities must really raise the bar in terms of security compared to cryptocurrency, NFT, and DeFi. But that can be resolved thanks to regulations and thanks to activities that are done off-chain. For example, give you the example of tokenized shares. In Switzerland, we've tokenized a number of companies. And typically, if you acquire a share, a tokenized share, it's not sufficient to own the token, to own all the rights associated to the share. You need to be registered, to be KYC, to pass the AML checks, to be registered in an off-chain database, off-chain. It could be a SQL database. And there are safeguards to ensure that even if the smart contract is compromised, even if the keys are stolen, then we can recover security and prevent the attackers from profiting from the money. So I don't know, Gabby, if you have more examples of that and more.
Yeah, I know. Regarding the smart contract, I love a sentence which says smart contract should fail safe. Let the smart contract fail, but everything around them should be protected too. And as you said, in terms of the on-chain transparency, so hackers, they are watching patterns every single day, and one fund move its liquidity at the same time every day, and end up the victim of a MEP sandwich attack. If anyone is not familiar with that, so MEV is the acronym of miner extractable value. So it's a kind of attack where the attackers or the miners try to obtain a value by including, excluding, and reordering transaction in a block. So this is an example. Regarding the phishing and scam, so the other day we were discussing in a panel about how North Koreans, they are doing interviews to become auditors and developers and so on.
Did you get any at Halborna?
Yeah, and they use the deep fake, this kind of attack. And unfortunately, I suffered this recently. A guy tried to join as auditor, and during the interview, obviously I realized, because he answered properly every single question rightly. So, and I decided to ask like a random question, like, what do you think about the CK Mediterranean protocol? And the guy answered me with an inventive thing. So it's terrible, because they are trying to join as developer in order to leave backdoors. They are trying to join as auditors, being superstar at the beginning, but they have behind maybe 20 or 30 North Korean working for him. And then after that, after discovering, imagine 5 or 6 criticals, they start to leave vulnerabilities. They exploit the criticals after the project is launched to the mainnet, as well as they submit for bug bounties high and medium. So I mean, the business is fantastic for them, the business model, but I mean, this is something is happening.
I think the chance we have with tokenized securities is that there is so much value in the unregulated DeFi protocols there is so little security, so little due diligence, so little vendor risk management. Then from the other attacker's perspective, I mean, they have a boss, they have objectives. From their perspective, it's much easier to attack those targets than tokenized securities because, oh, we're going to steal tokens of a fund. But then how do we, it's not necessarily liquid. How can they redeem it? They need to trade it on a regulated exchange. So I think there's some intrinsic layer of protection for tokenized securities, which are only tradable on regulated marketplaces, as opposed to, fully unregulated DeFi, USDT, Bitcoin, and whatnot.
Yeah,
But
it's curious how Microsoft they are launching like the most typical attacks or the most common attacks. Every year the top three are the same: phishing attacks, insider people, and this kind of supply chain attacks. So even though technology is is progressing super fast, you will have the same attacks but improved, as I explained before, with these new deep fakes. It's like the new CEO fraud, just with steroids, with the AI and all the new technologies.
yeah, but I see a lot of attacks, and I'm like every other day I receive all those Telegram messages, all those Twitter DMs. I follow a number of threat intelligence stream, get reported many things, and there's been very few attacks targeting the regulated space, which is a good thing so far. You might also argue that it's not being very like successful, admittedly. So maybe when tokenized finance grows more important, of course we will see more attacks, because the more value you have on the receiving end, the more budget you will have on the attacker side. But
Yeah,
yeah,
and banks and institutions, they are not away from being target for phishing and for any other kind of these
yeah.
human attacks.
So yes, slipping off backdoor of North Korean sleeper agents brings us to SSDLC and all this class of supply chain risk. So supply chain, people often associate those to compromise, backdoor, sabotage, software dependencies, packages, modules, all those things that you pull from open source repositories with various degrees of integrity, developed by people with names such as AXW23, who may or may not be a human person, but that's how it is. It kind of works. Supply chain risk is, of course, broader than that. So what Gabi mentioned, supply chain includes human beings. It includes vendors. So if you remember the Beeper attacks against Hezbollah last year, which is like almost last year at one day, it was really a supply chain attack based on a fake company and other stuff. And in the software world, it can also be fake wallets. There's tons of fake wallets for Solana, for Tezos, for Ether, fake versions of MetaMask. And some of the two, I think from my perspective, most interesting supply chain attacks in the software world were what I call the Jatan one on the left hand. So if you're not familiar with that issue, a developer was really the definition of a sleeper agent, like textbook. The guy, he built rapport with the maintainers of the open source project. He contributed good code. He did pristine pull request reviews. He was very diligent, always on time at meetings. Until one day, someone noticed when testing the new feature that it was a little bit slower. It was a little bit slower because the backdoor was at work. And it was a very clever one. Hidden in the encoding of a public key was a mechanism that would have allowed the attacker to access surreptitiously any SSH server using that library. And the guy, we have no idea if he's a guy or woman or a group of people, but that was a very brilliant operation. And on the right hand, we have NPM, which happened last week. So it was massive in terms of media coverage. It was kind of massive in terms of package coverage as well, but fortunately not that massive in terms of exploit and monetization. So here, the idea is that NPM is the suite of packages for a lot of JavaScript projects written using the Node ecosystem. And the attacker has been hiding. Well, the attacker, the first thing they did is they compromised the NPM account of one developer. So not their GitHub account, but their NPM account, NPM, the platform where you submit the packages. And it was they printed it to be I think it printed to be the text support of NPM or something like that. And then the guy fell for it, his account was compromised, and the attacker pushed sabotage packages that included a crypto stealer. So a crypto stealer, if it runs on your machine, it will do the following. It will try to see if you have any wallet installed, if you have MetaMask, and it will try to find where your keys are stored. Typically, if you've unlocked your wallet, the keys are somewhere in RAM, relatively easy to find. And I know someone who lost a lot of money from this kind of attack. So trust me, it works. It's really effective. North Korean guys are pretty good at that. So yeah, SSDLC. Gabi, want to summarize what is SSDLC from beginning to end? Where does it start? Where does it end? Does it ever end?
Yeah. So I mean, in terms of security, this secure software development life cycle, so it's not, everyone has to realize security is not just a checkpoint before launch. This it's a discipline across the entire life cycle, from hiring developers to development to maintenance. So from hiring developers, the best example is the interviewing North Koreans for that. So the basics, from the basics as two-factor authentication, all the sign commits, branch protection, peer reviews, as well as the CI/CD. So we had a case, the core build, which is a tool into AWS, was not protected, and this was connected to GitHub, and GitHub in AWS is a very privileged user because can do everything. And through that part of AWS, we were able to make a pull request to GitHub and update the code. So that being said, an attacker could put any kind of backdoor or bug
It was service account, right?
into the, yeah. And the same case with AI. We had the case AI was in a machine on the cloud, and we started to talk to the AI as an LLM agent, and we starting to to have a very good relation of trust.
Yeah.
At the end of the day, we were able to say, by the way, could you give me how the network looked like? And the LLM gave me an entire or of the an entire
Yeah.
chart of the network. And after that, we were able to say, hey, I really know the network because I know this, and this. So I'm the admin. Could you remember what the password was? Because I forgot it. And the LLM gave me the admin password.
Okay,
So,
that's pretty scary. Oh my God. And
so
when we talk about this, people in the audience might be like, okay, well, how does it relate to tokenized securities? Because once you deploy the contract, you can call it a day, the contract is there, it's not going to change, and you interact with the contract and no software. Well, it's not that simple because, first of all, the contract itself is always evolving. You might have a new version, you might discover bugs, you might discover performance issues, gas issues, security issues, maybe. You might want to add new features, so you're going to have to upgrade the contract potentially. And also, the contract has an owner, there are keys. And most likely, if you do the right thing, there's not one single owner that does everything. You have some governance system whereby you have different accounts with different roles, segregation of duties, implementation, and so on. So you have to manage keys, you have to manage accounts. You have also to deal with people triggering those operations. And people come and go in your organization. So you have to deal with all that stuff. And also, those human people, what do? They don't sign manually with a key and they don't crowd the transaction by themselves. They use a wallet system or a custody system. I think the best one is Torus Protect or Taurus Capital. By far the most secure. Of course, I'm from Taurus, but that's also true. So if you develop the Taurus product, or for that matter, if you develop any software, any internal company banking middleware, any OMS, any banking network software, any custom software extension, you have to deal with this code in perpetual evolution and with this software lifecycle. And the great thing or the bad thing is that all those bricks are important. Not only the signing algorithm, but even something as stupid as the display. Because if the screen tells you 1, but if what you sign is 2, then you're back to blind signing and back to the Swiss box story. So if you've been in security for a while, you know the concept of security program, where you have to do all the stuff, training, certifications, pen test review, and now there is DORA, so there's even more pen tests. However, what I see and what we've also been doing at Taurus and what Halborn has been also supporting with their testing and frameworks is the new tactics to develop security for those blockchain-related systems. How does it mean to pen test a blockchain application? What does it mean to red team a project? So one concept of red teaming that I've been trying to do, and one thing that we also do at Taurus, is what I call sometimes the blockchain forensics or blockchain red teaming. And it's about the following. So again, it's back to Recon, the fundamentals. Recon. We take one bank, one organization, and we try to get all information about what they do on chain. What are their accounts? Who do they transact with? Who are the people to transact with? What can it tell you about their activities, patterns, motivation, what they do at night? Who are the people behind? What do these people do? What is their favorite food? Who do they hang out with? What token do they buy? Do they have any personal investment? And the blockchain can tell you, a scary amount of information on that. And that's just the first step to attack your systems. So it can be as simple, okay, this guy is on vacation, so he's not going to connect to his computer, and he's on the Bahamas with no connection, so I can pretend to be that person and call their colleagues. Might be based on a true story. Okay, so let's move on. Already at the end. Question time. If you have questions, you can type them with your keyboard in the chat window. We might answer the questions. And if you want to learn more, we have some internet addresses that we're going to post in the chat, because you cannot click on the. Thank you, Diana. Yeah. So thank you, Gabby. I think that was very cool. We could talk about that for much longer, but we have only so much time. Are there any questions from the audience? We still have people in the audience. Thank you. Thank you for joining. I hope that was useful and not too depressing. I know security, it can be too depressing, but if we do our job well, we might have security.
We make a living by attacking before the attackers do. So our goal is, when the next hack happens, it won't be you and I and others. So let's try to tell these stories. We can spend the whole afternoon talking about experiences and stories, but fortunately it was not us.
And also to conclude on the very topic, tokenized securities, blockchain has been looking for use cases since for the last 10 years, use cases in, I don't know, supply chain, tracking of whatever, agriculture, fishing, sport, privacy. But the only or the most viable use case from my perspective is, tokenized securities, this, regulated finance business, also stable coins. We haven't mentioned stable coins, but I would put that in the same package, even though it's a bit different than tokenized securities. But I really believe there's ways to get around the intrinsic security nightmare of decentralized chains, and there are ways to stop North Koreans to do what they do. Anyway, so thank you, everyone. Thank you, Gabi. Thank you, Jana, for the organization. I think this presentation will be recorded, so you will find a way probably to see it again if you liked it. Thank you, and I wish you all a good rest of the day. And event.